Hello everyone, myself Girish with SOLIDWORKS tutorials. Uh, Today here I'll just go ahead with the basics of SOLIDWORKS flow simulation, and main concentration is towards centrifugal pumps. So we'll just go ahead with the basics of all the pumps, how it works, and what and all the basics we need to know to deal with the flow analysis on the centrifugal pumps and even the multi-stage pumps. So you could see the images here, the components of the centrifugal pump, as well as the introduction there, right? So what exactly these pumps does is they convert the mechanical energy into the hydraulic energy, that is pressure energy. Okay, by virtue of centrifugal force. The main source is the centrifugal force to deal with these all the concepts. Okay, so the flow is radially outward direction. So as you could see in the image, right? And then common uses for this centrifugal pumps to just deal with the water transportation, as well as the sewage, petroleums, and the petrochemical pumping. These works on the principle of the forced vortex flow. Means when a certain mass of the fluid is rotated by external torque, rise in pressure head takes place. So what exactly happens is, due to the torque produced by the shaft, the pressure will be created due to the vanes and the radial vanes. So that pressure head will help us to force the certain mass of fluid along the axial flow. Okay, so this conversion of energy occurs by virtue of the two parts of the pump. One is the impeller and the casing. So what exactly this impeller is, so this is the rotating region, so which converts the driver energy into the kinetic energy. Okay, that is pressure energy into the uh, kinetic energy. And this diffuser, the casing stators, will convert the kinetic energy into the pressure energy. Okay, the vice versa. So by this, the multi-stage will able to produce the more pressure head and the more flow accordingly. And you could see, as I said, means here, so which will rotate, and this is the suction eye. From there the water will be sucked inside, and these are the volute casing. So wherein here the more pressure head will be created due to this particular shape of the volute. Okay, this is the discharge and the impeller. Okay, as you could see, the same thing here, the explanation about each and every component. So we'll see the diagram here explains the same, the pressure side. So from here the pressure will be created, and this is the output, and this is the suction side where the water will be sucked inside. And these are the impeller. This is the closed impeller, we could see, right? So there are two types, one is open and closed impellers, right? And then this is the driver shaft, so which will help us to rotate this particular impeller. Yeah, and this is the volute chamber where the output water, the with high pressure, will be uh, forced outside the pump casing. Okay, and the rotating direction indicator, how exactly it's gonna rotate. Can you see? This is kind of anti-clockwise, we can say. So in centrifugal pump we have the two components, as I explained. One is the rotating component, they are called as the impellers, and the shaft. Shaft will uh, help us to rotate the impeller, right? And the stationary components comprised of the as I said, the casing and the casing cover and the bearings as well. The rotating components, the impeller. So what exactly it does is, so it is the main rotating part which will provide the centrifugal acceleration to the water or any petroleum products. And shaft, which is the power source, so which will transmit the torque and encountered when starting and during the operation as well. Okay, to start the pump, so the shaft will provide the torque or the power required. Okay, it will also support the rotating other components as well, remember that. As I said, there are two types of impellers. One is closed and the open type impeller, and these are the vanes inside, so which will help us to just force or depressurize the fluid inside. We have seen the rotating components. Now we'll have a look on the stationary components. The casing. The main purpose of the casing is to convert the kinetic energy into the pressure energy, as I said before. There are different types of casings: volute and the vortex and the circular casings. So the main concentration is towards the volute, so which is used for producing more head, that is eddy current formed. So if you are going to deal with the vortex casing where the eddy currents are reduced, okay, the circular casings will just reduce the heads. Okay, well, the volute, as we have spoken about this, so this is the curved funnel increasing the area to the discharge port. Where the area of the cross section increases, the volute reduces the speed of the pressure there, and by increasing the pressure of the liquid. So as we have seen in the image, the volute does the same. So again, vortex casing and the circulation explanation, you could just go through this. What exactly the priming is, very important steps. So we have already done this activities. If you are a farmer or your colleagues or farmers or your relatives does this particular farming and all, that time we have seen this priming work. What exactly it is? It is a process where we'll fill the water inside the suction pipe and the casing and the delivery pipe up to delivery valve with the water. So that what exactly happens is it removes the air from these parts. So due to that, we could able to create the suction inside. So it is, there are two types of priming. One is positive and negative priming. Okay, one is for speeding up, one is for slow down. Okay, the working, how do they work exactly, what and all the process will take place. So the image explains the same. Inlet will be there. From there liquid and enters into the impeller stage. Okay, that is, liquid is forced into the impeller. Then again there are impellers. Inside the impellers will be having the vanes and all. Okay, this vanes will convert the pressure energy to the kinetic energy. Okay, the liquid rotates and leaves the impeller. So once vanes rotates with respect to impeller and the shaft, the water will be discharged into the volute. So as I said, this volute converts the kinetic energy into the pressure energy. Due to that, the pressure head will be more. Okay, and then this is the outlet where you will place the flanges and all, and then again extension pipes. Okay, so as I said, it consists of impeller rotating within the casing. So these are the impellers and the yes, vanes. So and this, what exactly happens is the liquid is directed into this center. So the impeller picks up these all the fluids due with respect to the vanes, and with this rotating components, the shaft rotation, the impeller accelerated to a higher velocity, so that the rotation of the impeller and the discharge will help us to gain the centrifugal force inside the casing. Due to this centrifugal force, the water will be forced into the volute, wherein the pressure head will increase due to this particular the rotation of the impeller. Okay, yeah, so these are the velocity triangle. So very good to just see how exactly the output and input velocity will produce the resultant velocity. Okay, so these are the few velocity diagrams with respect to the forward facing vanes and the radial vanes, and even we have the backward facing vanes. So these are the different vanes here. Okay, the forward facing vane will produce the uh, resultant velocity like this. So if we have the radial vanes, the angle of attack will be 0. For that, the output formula is different. We'll see that one later. And these are the backward facing impellers. So depending upon the utilization, these will differ. Okay, the explanation here, you can just go through this. The formula here, the work done by the impeller on the water is this one, the work done, which is equal to will component of the absolute velocity. So that is the outlet velocity of the will component into velocity outlet of the impeller. Okay, tangential velocity of the impeller outlet. So same thing here, the absolute velocity of the will component inlet and the tangential velocity of the impeller inlet. Okay, divided by g. So this formula will change if your blade angle is 90 degree, as I said. So the will component inlet becomes 0. So due to that, the work done formula is this. Okay, yeah. The heads in the centrifugal pump, there are different types of heads. One is the suction head, delivery head, and the static head, and the manometric head. So what exactly this static head is? So we are mainly going to deal with that, the sum of the suction head and the delivery head, that is output head, we can say. The same thing, explanation is here, we can just go ahead with the same. Yeah, coming to the same thing. So this is the suction pipe and this is the delivery valve, casing, impeller, the rotation of the impeller, and the discharge and the heads, suction and the delivery head and the total head. Okay, yeah. Efficiencies. So there are two types of efficiencies. One is manometric efficiency and the mechanical efficiency. Manometric efficiency is the ratio of the manometric head to the head imparted by the impeller, and the mechanical efficiency is the ratio of the power delivered by the impeller and the power output of the shaft. Okay, same formula into divided by the power input of the shaft. Okay, output to the input. So the overall efficiency is the ratio of the power output to the power input. So same formula here. So from this you can able to just find out the overall efficiency of the centrifugal pumps. Okay, there are different characteristics of the curves are there. So there are three main curves. One is the characteristic curve and the operating characteristic curve and the efficiency curve. So these curves will help us to predict the performance and the behavior of the pumps, okay, under different conditions like pressure heads and the different heads, and even we can consider the flow rate and the different speed levels. So this is the operating characteristic head curve. So head versus the GPM, okay, how the efficiency is changing with respect to the capacity, and the flow rate versus total head. This is the efficiency curve with respect to the head. The flow rate will change like this. Okay, so we have seen the up to now single stage centrifugal pump. Okay, again there are multi-stage centrifugal pumps. One is series centrifugal pumps, that is V1, V2, V3 like this. It is used to produce high pressure head. Parallel, I haven't seen much, so it is used to discharge the large quantity of liquid. So this is mainly used in petroleum industries and all, so not much. Okay, so we have mainly the series multi-stage centrifugal pumps. We'll concentrate on it. So this is how the series centrifugal pumps are designed. One is the impeller and then stator and the impeller against stator, and this is the shaft which will drive everything, suction and the output. Okay, this is the example for the same. Okay, there are 1 2 3 4 5 5 multi, like 5 stages are there. Okay, this is the shaft which will rotate the vanes and the impeller to produce the pressure head, high pressure head and high pressure, exactly. Okay, the input and output you could see. Yeah, this is the parallel combination. So I haven't seen this kind of machines somewhere, not even once. You can see this kind of machines will be there. Okay, the pumps. Well, so very important factor, the cavitation. So why this cavitation happens and what exactly the cavitation is. So this is the phenomena where the formation of the vapor bubble, where the pressure falls below the vapor pressure of the flowing liquid. Okay, due to that what happens is the vapor bubble causes the high pressure, results the pitting action on the metallic surface. Okay, erosion we can say. So due to this particular cavitation, the noise and the vibration and even erosion will be produced. That we'll see here. Could see this is the you can consider the impeller cavitation damage. How exactly the damage will place here, and the high pressure regions and the low pressure regions. So here you could understand the same. So this is the damage area. Okay, the high pressure region where the erosion is there. Okay, and this is the low pressure area. Due to this kind of damage of the vanes will happen into the impellers. Okay, this is the rotating impeller. Okay, yep. So these are the few basics, and finally we have the effect of cavitation. So what exactly happens is the metallic surface are damaged, cavities are formed. We already seen that one. Efficiency of the pump will definitely decrease due to this, and the unwanted noise and the vibrations are produced. So this is the initial stage as well. So if you are finding this one, so you should better change the impellers or make some modifications or replace it. Okay, yep. So that's all about the basics of the centrifugal pumps and multi-stage pumps. So we have seen from basics to types and the working principle, formulas and different characteristic curves and multi-stage centrifugal pumps. Okay, yep, that's all about this session. Thank you, stay tuned. Bye everyone.